What we have here is actually a straightforward plant location problem of a type that you might often encounter. What I'm going to show you is how to compare locating the plant either in St. George or in Albuquerque. That's the nature of this particular problem. If we look at this closely, you'll see that in this instance what we've done is project demand from 2015 to 2016, and all that amounts to is involving some projection of the initial volume to get to 2015, and another projection that says, okay, we're going to have 2% growth from here to here. All these are our growth factors. So we have initial demand in cases here, and then this is the projection for the following year. And so all that is if you look up here, it's multiplying by the projected growth rate. And here again, it's expected to grow again. This then converts that number into a volume in cubic meters, because that's what you're going to transport in this particular case. So that's taking demand and understanding that this is how demand is going to change. Now, these things involve the cost, and they're going to show up later as part of the cost. So 2016 projected demand in this case is 1,096.5. Phoenix, Fresno, and Santa Fe can each provide 180,000 cases, or 540,000. So obviously they need more capacity in order to meet this demand. In this case, capacity, and keep in mind, is a constraint. It limits how much you can make. You can't make more than capacity in the math, and in fact in real life you can't do that either. So what we're looking at is this situation where if we were to blot this all out, we'd have 0 in there, got nothing. And here, because what we're doing right now is analyzing St. George, i.e. Albuquerque in this case is given 0 capacity. So what we're going to get out of this particular model is what things look like if we build in St. George. And that's going to be the transportation cost. We're saying, this is just an assumption given in the problem, $3 million to build there, there's total cost. Now you've got exactly the same problem down here, except this time St. George is zeros, it has 0 capacity, and the 800,000 is being built in Albuquerque. And you get the total cost and the total cost. So St. George appears to be the better option when you add in all of the costs. There are several things involved in the nature of this problem. So if we go up here and take a quick look in data, you will see, of course, in the usual fashion. We'll go up here, go to Solver, and take a look at how it's been solved. Obviously, in each case, each time you run the solver, you're going to have a target, and in this case it's here, because it's left over from Albuquerque. That's where the minimization is. And what we're changing are the variables inside the matrix here. You'll see that that's what this is. C53 through G60. Here, to here. And you have two constraints. The first is C61 is less than or equal to C51, G51, i.e. that's the capacity. I.e. you can't use more than your capacity. The second constraint is right here. And that constraint is you have to meet all of the demand. And so we're putting the demand right here. Now it doesn't matter where you put this stuff, as long as you point at it correctly in here. You can put it anywhere you want to. As long as it's pointed at correctly in the constraints, not going to be a problem. But what that means is all the demand has to be filled, and you see that this is a less than or equal to when you build a constraint, so it has to be less than or equal to the capacity. The type of problem is a simplex LP. It's a linear program. Subject to these complaints, it is minimization. And if you run the solver, you'll get the results that you see there. Now, what I'm going to ask you as a test problem is very simple. And I'll keep it simpler than the whole complex process here. I will simply ask you to put another location in here, i.e. go find me some different mileages, find me a different location, put the correct mileages in there using Google Maps, and then run the solver again. That's the nature of the problem. I'll have an alternative problem up there for you, but this is the basics, and I'll put up another video to walk through the setup from a blank problem. At any rate, that's my story for the moment, and we'll try it again over the course of the semester to get it all blocked out. Thanks.